recording. Share my screen. Okay, so so welcome to the practical lecture. So as I mentioned in class last week, today's practical, or this week's practical, is going to be based on multi-threading. So I won't say much about the practical, but everything that I'm going to cover in this practical lecture will be a subset, although not everything that the practical will require you to do. If it was everything, then I'd essentially be giving you the answer to the practical. So, so what we will do is we'll create one task class. So we'll just create a task. Let's say that generates a random number. And then we will add the task to a thread, or rather we'll use a thread pool to create threads to run tasks of that nature, right? So, so we'll have all of these tasks, and then we'll give them to a thread pool, and then the thread pool will assign threads in order to run the tasks for generating random numbers. Yeah, so let's do that. So the first thing that I'll do is I'll create my main. And let's just do that. And then what we will do is we will create, so let's create a list of numbers. So let's say, for example, or rather, let's just create a task. Yeah. So new package, and then I'll place this in axc.computerscience2a.thread. And I will create a class that implements the runnable interface. So I'll call this a generate random number task. So it's a task for generating a random number, and it implements the runnable interface. Okay, so that's that. And so what's going to happen here is I'm going to calculate the random number. But let's say before I calculate the random number, let's say this task, for example, has an ID. So let's say every task that I create must have an ID. So let's make that an int. And yeah, so let's just leave it at that. And then all this task has to do is generate a random number. And after generating a random number, it will then output the random number as well as its ID. So system.out.format. And so I'll just say task, and then I'll provide the ID. So the ID is a string. Oh no, it's an int. So let's provide a number. And let's then provide the random number. So the random number will be also a int. So let's make it a decimal or a digit in this case. And then after that, let's end the line the way that we usually do by going into the next line. Yeah, and then so here we generate a random number. So int random number is, let's create a random object. Yeah, and we'll just say this is random dot next int. Yeah, and then so we want to output the ID as well as the random number. So ID rand int. So that should be fine, but then how we're going to set the ID, let's say we set it using the constructor. So public generate rand task. And this takes an ID as a parameter. And we use this to set the ID. Yeah, and that's basically that. So all this does is it generates a random number and it outputs this string. Yeah, so then what we will do is, let's say in main, then I'll create all of these tasks. So I create the first one, so generate rand task. Then I'll just say task one. And let's provide the ID. So let's start from 0. So task 0. And let's generate another one. Let's create another one. Call this task 1. No, I do not. Probably my colleague. Sir? So you'd have to go to the Academy of Computer Science. So if you go to the reception and you ask for Mr. Makanlo, then he'll be able to help you. Yeah. Yeah, so sorry about that. But yeah, so let's continue. Yeah, so we've created that. Let's create another one. Task 3. Actually do this. This should help you the practical as well. So generate rand tasks. Yeah, so let's do that. New array list. Yeah, so and then so let's just create a loop. Create 10 tasks. And then just say tasks dot add new generate, and let's say the ID is I. Yeah. Okay, so we have that. And then now, obviously, if we want to execute all of these, the usual way, we would have to create a thread for each task, right? But that is expensive because if we had 1,000 tasks, we would have to have 1,000 threads. If we had 1,000,000 tasks, we would have to have 1,000,000 threads, right? So that's not what we want to do. But instead, we want to use something called a thread pool, which will generate, create thread objects on request, and it will not destroy those objects, right? It will keep them somewhere in the pool so that when we want to use them again, we can use the existing thread without having to instantiate new ones, right? In order to do that, I'll create another class, and I'll pull this task executor. And this will also implement runnable because, as you will see, we will run this executor using a grid. So let's have an array list, generate rand task. So tasks. So this will have its own reference to the tasks and just create a constructor for it. Executor takes an array list on generate rand tasks. And then what we'll do here is we will then do the assignment. And then so what we'll do now is, so after doing that, then we will essentially execute each of these tasks. So in order to do that, I will create a thread pool. So the way in which we create a thread pool in Java is by using something called an executor service. Why is it not allowing me to? Let me just do this. Pool, import executor service. You'll see it's in the concurrent package because it has to do with concurrent programming. Okay, so then I create a cached thread pool, so a new cached thread pool, and the way in which I do that, I call so it's a static method, and it exists inside of the executors class. And now that I have that, then I can execute all my tasks. So then I can say for each task, so generate rand task in tasks. I can say thread pool dot execute the task. Yeah, so that's pretty much what I need to do. And then after doing that, then I need to shut down the thread pool so that I release all the resources because I won't need to use it again. So thread pool dot shut down. So actually the best way to do this, because this can take a while, is so let's actually do this. So I'll call the shutdown method here, and then I'll say while this is active. And this method, oh, thread pool. Yeah, so if it's not yet shut down, so I'll just wait. So this is a better way to do this. And here, I will not put in any code. So I'll just wait for the thread pool to shut down so that I can continue with my program sequentially, right? Because if this does not shut down, my program can result in undefined behavior. It can do things I do not expect it to do. So I need to wait for it to shut down, be sure that it is shut down, and maybe output a message and say, so let's just output it in red and just say, has shut down. Yeah, so the virtual has shut down. And then so now all I need to do is, so I have all of these here. So I need to create my executor. So task executor, Let's say thread pool executor is new task executor. Okay, and I provide the array list tasks. Okay, and then now, so what I do is in order to run this, remember this class implements the runnable interface, right? So I need to create a thread. And provide the runnable object. So thread for executor. And then so after doing that, then I can start the thread. Start thread, and then I can output a message and say thread done. Let's just say main method done. So we can keep track of what's happening here. So let's just check before we run this. We created 10 tasks. And a generate rand task basically takes an ID and it generates a random integer. So let's put a bound on this. Let's say the maximum is 100 minus 1, 99. And then it outputs its ID as well as the generated integer. And so we create 10 of these. And then we create a task executor. What is the task executor? It's this class that implements runnable as well. And it keeps track of this array list of tasks. And we can set it using the constructor. And the run method basically creates a thread pool. And for each task, we simply execute the task. And when we are done, we shut down the thread pool and we wait until it's shut down. And when it has, then we will say that the thread pool has shut down. And then so in order to run that, we create a thread in main and we add the thread pool executor in main, start the thread, and we then output that the main method is done. So let's see what happens. Here, this is weird. So main method done, thread pool has shut down. Sorry, I'm in the middle of a lecture now. Okay. So if you please, please excuse me, I'm giving a lecture now. Okay, so now then what we do is, so actually we already output our values. So this is weird because this is supposed to be output when the main method is done, and we are supposed to see this after all of this has run. So the reason for this is because this is concurrent programming, and we can't really determine which instruction is going to be, or rather which string is going to be output first in the output stream, right? Because this is a multi-threaded application. So we can try to enforce some order here in terms of what we see. And in order to do that, we can use the thread.join method to make sure that we allow this thread to execute until it is done executing before any other instruction is executed, right? So in order to do that, we do this. So we just call the thread.join method, but that has the potential to throw the interrupted exception. So we need to surround it with a try catch block. Right? So try thread.join and then catch the interrupted exception. And let's see if that does introduce some kind of order. So the logic here is we want this thread to execute until it's done before any other instruction is executed. So if you run this, then you'll see that quite makes sense, but we're not there yet. So thread pool has shut down. So that is good because this happens here, right? So while the thread pool has not shut down, then we wait and then we say that it has shut down. And then, So, but now it says, so this is output, and then only then do we see that. Okay, so let's just see. Okay, so let's just run this one more time. Okay, same thing is happening. So let's try to do something else. So let's say, for example, before we output this random number here, what we're going to do is we're going to call the, let's do this. So let's say thread dot sleep, and let's wait for, let's say, 2 seconds. And that's going to throw the interrupted exception as well. So let's just wait before we actually output this, and let's see what happens. Okay, so now we have another problem. Yeah, so let's rather, okay. So what happens here is, so that is fine. Then execute. Okay. And then, oh yeah, so that just waits for too long. So let's say 500 milliseconds. Okay, so that's, okay. So thread, executor. And all of these are runnable tasks. But technically speaking, this should eliminate this problem. So let's just check if we don't output that, what happens? Oh, yeah, okay. This doesn't really matter. Just here, 200. Still the same issue. Yeah, so it's probably a tiny thing that I'm not seeing right now, but yeah, it's acting really, really weird. Just see, that's not supposed to be the case though. Main message, yeah, so call the join message here. Yeah, okay. So unfortunately, I can't see what I'm doing wrong here, but do not worry. Anything I did here does not have a bearing on the outcome of your practical. So this was just me trying to do something else. Okay, but yeah. So ideally, what should happen is if I call the thread to join method, this is supposed to wait for this thread to execute and be done, and only then should I be able to see this output here. So there's definitely something weird here. But in any case, this is how you can use a thread pool to execute threads, right? The most important thing is when you're running the task executor, you make sure that you create the executor service object, which is basically a cached thread pool, and then you iterate through each task, and you simply execute the task, and then you shut down the thread. If, for example, just to show you guys what happens if we do not really wait for it to shut down. I just want to show you guys how long it can take for a thread pool to shut down. So, okay, that was really quick. Okay, yeah, this compiler is not liking me today, but usually it can take longer than this. So, but yeah, so in this case, that was really quick. Let me check something. Okay, but yeah, that would produce that first effect. Yeah, okay. All right. So, for some reason, we don't have to wait for that to happen now. So, unfortunately, you won't get to see that. But this is the crux of what I wanted to show you guys. Yeah, so good luck with your practical. I will upload a practical. There's just a few things that I need to do before I do that. So it might be at the end of the session, or it might be tomorrow morning, right? But it is really a straightforward practical. It shouldn't take you more than a day to complete. Yeah, so thank you very much. So because I'm going to invigilate the SSA as well, you are welcome to leave the venue if you want. So enjoy the rest of your afternoon and all the best.